All right, 8.1, we're going to learn about sequences and series. So a sequence is an ordered list of numbers. A finite sequence is a function that has a limited number of terms. So we have finite, and then we'll see infinite, which infinite would be unlimited. So finite is a limited number of terms whose domain is the finite set 1 through n. The values in the range are called the terms of the sequence. So we're going to have like some number that's going to be our first term of the sequence, and that'll be term 1. We'll have another number, that'll be term 2, and so on. An infinite sequence is a function that continues without stopping and whose domain is a set of positive integers. Here are examples of finite sequence and infinite sequence. So we see here finite sequence, it's just 2, 4, 6, and 8. It stops. Infinite sequence has that ... so it just keeps on going. A sequence can be specified by an equation or rule. So some of our questions that we'll see will ask us to come up with a rule, and that's an equation to how we can find the next term in our sequence. And for both sequences above, it can be described by the rule 2n or f of n is equal to 2n. So either one of these, same thing. So this is just our equation that no matter what number we plugged in for our term, we would get that number in our sequence. So let's look at example 1. It says write the first 6 terms of a sub n is equal to 2n plus 5. So this is A. So we're just going to plug in 1, 2, 3, 4, 5, and 6 because we have to find the first 6 terms. So we have A sub 1, because we're plugging in 1 for n, is equal to 2 times 1 plus 5. What's 2 times 1? 2. And 2 plus 5? 7. Next, we have A sub 2 is equal to 2 times 2 plus 5. What's 2 times 2? 4. And 4 plus 5? 9. Next, we plug in 3. 2 times 3 plus 5. What's 2 times 3? 6. And 6 plus 5 is 11. Then we have A sub 4. So 2 times 4 plus 5. 2 times 4 is 8. And 8 plus 5? 13. A sub 5 would be 2 times 5 plus 5. 2 times 5 is 10. 10 plus 5 is 15. And then lastly, we have A sub 6. So 2 times 6 plus 5, 2 times 6 is 12, plus 5 would be 17. So these are our first 5 terms. I want to see your work when you do this, so I want to see what you're plugging the number into. I need to see your work. So don't just write 7, 9, 11, 13, 15, 17. I know you guys can multiply times 2 and add 5 in your head, but I want to see your work. So everybody sees how, depending on what term we're on, this is the first term, we plugged in 1. This is the second term, we plugged in 2. Third term, 3. Fourth term, 4. And so on. So all we do is just plug in 1 through 6 for n. Let's look at B. B is the same thing. It's written f of n, which is the same thing as a sub n. We're just plugging in 1 through 6 for n again. So f of 1 would be negative 3 to the power of 1 minus 1. What's 1 minus 1? 0. And what's negative 3 to the power of 0? 1. So our first term is 1. Now we need our second term, f sub 2. F of 2 is equal to negative 3 to the power of 2 minus 1. So 2 minus 1 would be 1. What's negative 3 to the first power? Negative 3. Next we're going to plug in 3. So negative 3 to the power of 3 minus 1. 3 minus 1 is 2. What's negative 3 to the second power? 9. Then we plug in 4. Negative 3 to the power of 4 minus 1. So negative 3 to the power of 3. Positive or negative? Negative. Negative 27. Next we plug in 5. Negative 3 to the power of 5 minus 1. So negative 3 to the fourth power? 81. And then we have f of 6. So negative 3 to the power of 6 minus 1. So negative 3 to the fifth power is what? What is it, Brooke? Negative 243. Awesome. So the next page is just some more examples of those. Let's look at number 3 because it's just a little bit different. It tells us, again, to find the first 6 terms. So we have a sub 1 is equal to, we plug in 1 for all of our n's. So what do we get here? 1/2. Awesome. Next, we're going to plug in 2. So we plug in 2 for all of our n's. What would this be? 2/3. Next, we have a sub 3. So we plug in 3 for all of our n's. What do we get? 3 over 4. Next, we plug in 4. What would this be? 4 over 5. Next, we plug in 5. What do we get? 5 over 6, and then we plug in 6. What do we get? 6 over 7. So again, for these, I need to see your work. So even though you're just adding 1 plus n, not much is going on, I need to see all of this. Alright, example 2. Here we're writing our rules. So we're coming up with an equation for how we come up with these sequences in our term. And our terms in our sequence. Oops. So when the terms of a sequence have a recognizable pattern, you may be able to write a rule for the nth term of the sequence. So describe the pattern, write the next term, and write a rule for the nth term of the sequence. So let's look at A. What do you think's happening here? So I always like to look at it and see, am I adding the same number to get from one to the next? No, there's too much of a gap. Here I'm subtracting 7, here I'm subtracting 19, so that doesn't really help us. Next I want to think, am I multiplying by the same number to get to the next? Here I'm multiplying by 8. Here I'm not multiplying by anything to get to 27, because 8 doesn't go into 27, so nope, that doesn't help.
I think I got it.
What'd you get? Awesome, good job, Brooke.
I really did it like that.
A lot of these problems you can just do in your head to come up with a rule, but it does require thinking and practice, because you'll start to see the patterns kind of happen again and again. So this is our first term, this is our second, this is our third, this is our fourth. We kind of want to notice what what do we do to 1 to get to 1? What do we do to 2 to get to 8? What do we do to 3 to get to 27? Brooke said we cube it. So this would be n cubed. But if we notice they're all negative, so it's actually negative n cubed. Which you can put it in parentheses or outside of parentheses, because if it's in parentheses, when it's cubed, it's always going to be negative. Or if you put it outside the parentheses again, it's always negative, so it doesn't really matter. And then we always just name it a sub n. Or you could say f of n is equal to. So same thing. That was a good job, Brooke. So again, these take some thinking involved. Let's look at B. So this is our first term, this is our second, third, fourth. This one's tricky. We're not really multiplying by the same thing to get to the next one. We're not adding the same thing to get to the next one. Let's see. Any ideas of what we're doing? What times 1 gives us 0? 0. What times 2 gives us 2?
1.
1. What times 3 gives us 6? 2. And what times 4 gives us 12? 3. So we're multiplying our term, so n is our term, and we're multiplying that by 1 less than our term. So we're taking n, we're multiplying it by something that is 1 less than n. So how would we write 1 less than n? How could we put that in math terms? 1 less than n.
Like the left term.
Minus.
Minus. N minus 1.
Times n.
Times n.
Oh, thanks.
So this would be a sub n is equal to n minus 1 times n. And when you come up with the rule, it always helps to plug in like 1, 2, 3, and 4 just to make sure it makes sense. So if we plug in a sub 1, that would be 1 minus 1 times 1. So this would be 0 times 1, which is 0. If we plugged in a sub 2, we get 2 minus 1 times 2, which is 2. If we plugged in a sub 3, we get 3 minus 1 times 3, which is 6. A sub 4. 4 minus 1 times 4, which is 12. So yeah, makes sense. And I think for these problems, we also have to write the next term. So let's find a sub 5. So this would be 5 minus 1 times 5, which would be what? 5 minus 1 is 4, and 4 times 5?
20.
20. And then let's find a sub 5 for the one before also, this one. Yeah. So for a sub 5, we just plug in 5 for our n's. We have negative 5.
Negative 125.
Awesome. Negative 125. All right, let's look at number 4. So describe the pattern, write the next term. We're not going to have to graph the first 5 terms, so you can cross that out. And then write the rule for the nth term. So let's see what's going on in our pattern for number 4. What do we do to get from 3 to 5?
Add it by 2.
Add 2. What do we do to get from 5 to 7?
Adding by 2.
Add 2. And from 7 to 9?
Adding 2.
Add 2. So this is our first term, our second term, our third term, and our fourth term.
So would it be like a sub n is equal to n plus 2?
Well, if we had n plus 2, let's just say n plus 2. Let's take 3. 3 plus 2 is 5, not 7.
Yeah.
So we got to do something else to it.
Oh, times n. Like n plus 2 times n.
Let's try that. n plus 2 times n. If we plug in 1, that would be 3 times 1, which works. If we plugged in 2, 2 plus 2 times 2, that would be 4 times 2, so too big. But you're on the right track. Let's try that. N times 2? We just tried that one. Because if we did n plus 2, 3 plus 2 is 5, not 7. So remember, these are our n's, so this is what we're plugging in.
N times 2 divided by, or minus 1.
Let's try that. 2n minus 1. If we plug in 1, that would give us 1. So let's try plus 1. 2 times n plus 1. So if we plug in 1, 2 times 1 is 2, plus 1 would be 3. Let's say we plug in 3. 2 times 3 is 6, plus 1, which is 7. If we plug in 4, 2 times 4 is 8, plus 1 is 9. So it works. Good job. So that is our rule. It's our equation that we get this series with. And then let's find our fifth term, so a sub 5.
B11.
11. Awesome. If you notice, these are like consecutive odd numbers. This is the formula to come up with consecutive odd numbers. So anytime you see like odd numbers in your series, it's going to be this formula. If you had even numbers, it would just be 2n. So the example that it gave us on the second slide were even numbers, and it was 2n was our equation. So you'll see that one pretty frequently. All right, let's look at number 5. So we have our first term, second term, third term, fourth term. Let's try that. N squared minus 1. So if we plug in 1, that would be 1 squared minus 1, which is 0. So it doesn't work. But let's plug in 2. If we had 2 squared minus 1, that would be 4 minus 1, which is 3. So if we plugged in 2, that gave us 3. If we plugged in 3, 3 squared would be 9 minus 1, which is 8. If we plugged in 4, this would be 4 squared, which is 16, minus 1, which is 15. So we're close. We're on the right track, but we're like off a number, because here we're plugging in 2 and we get 3. So we're off a bit.
I don't know about that.
What can we do to n to like make up for being off one number?
Adding.
Yeah, let's do n plus 1 squared minus 1.
Oh.
See if this works. So if we plug in a sub 1, we have 1 plus 1 squared, which is 2 squared, so 4, minus 1 would be 3. If we plugged in a sub 2, we get 8. A sub 3, we get 15. And a sub 4, we get 24.
Is there like a learning curve for this?
Yes.
Or
Like I said, these require thinking and practice. So you start to see like patterns occur more often. And the ones from the notes are harder than the ones from the homework. And they'll be harder than the ones that you see on like a test or quiz too. These are challenging, I will admit. They're challenging. But I'm good that you get to see these in the notes and think about it for a bit. What would a sub 5 be? 35. Awesome. All right. Let's look at 6. So we have our first term, second term, third term, fourth term. We're multiplying by -2 each time. When you multiply by a number each time, that's like your base and your n is the exponent. Because let's just say we did like 3 times -2, that's not 4, we're off a bit. But when you're multiplying by the same number each time, your n is going to be your exponent. But we're still off a little bit here. So we have -2 to the power of n. If we plug in 1, that gives us -2. So we're off a little bit. What exponent do we need to get 1? If we had -2 to what power would we get 1?
0.
0. So how can we change 1 in our exponent that it is now?
-1.
And
Like
minus
n.
1. So let's check this. We have -2 to the power of n minus 1. So -2 to the power of 0 is 1. A sub 2 would be -2 to the power of 2 minus 1 is 1, so that would be -2. A sub 3 would be -2 to the third power, which is +4. So I think we're right. We're definitely right. Let's see what happens when we plug in 5. What would our 5th term of our series be? +16. Awesome. Yes. The more you practice, the easier they become.